Alright guys, so we're going to look at this last slide here. So what we're going to do is get a little practice and just finding the inverses. Alright, so the first one's probably the most difficult one. So what I want to do is let's jump down to the second one. Let's look at that one first. What we're going to do is we're going to go through and find the inverse and then we're going to verify. Alright, so looking at what we did a little bit earlier. Alright, so the first thing in finding my inverse is I'm going to take my f of x and change it to y. We're going to say y equals 1 over x minus 2. If you remember from earlier, the next step after we change my x and y is I'm going to flip my x and my y value. So my x is going to go to my y is going to go to my x. It's going to look something like this. 1 over y minus 2. Alright, so from there, like we talked about earlier, we want to get my y value by itself. Alright, so what I'm going to have to do here is I'm going to have to multiply by y minus 2 on both sides. I'm going to move this over just a little bit. So multiply by y minus 2 here, because I got to get rid of my fraction. And multiply by y minus 2 over here. So those are going to cancel right there. Again, trying to get rid of my denominator, trying to get rid of that fraction. So that's what I want to do. Now, on my left-hand side of my equation over here, what I want to do is I want to take my x and distribute to both pieces. Alright, so when I distribute it through, I get x times y, which is xy. Then I get x times negative 2, which is negative 2x. And I'm left with the 1 over here because again, my denominator, the y minus 2 cancel. So that's what I've got. Now, I still don't have y by itself, so we need to go through and figure out what else we need to do. All right, so right now I've got a y here, so let's start the process of getting it by itself. So let's move this 2x over. Let's take this 2x right here and let's move it over to the other side. So since it's a minus 2x, I'm going to add 2x. Get rid of that line, there we go. Add 2x here, and I'm going to add 2x to the other side. So those cancel. So I'm left with xy equals 1 plus 2x. Alright, so I'm almost done. I almost got my y value by itself. So the last step I need to do, notice this is x times y. So the way we undo multiplication, or the opposite of multiplication, is division. So to get y by itself, we divide both sides by x. So those cancel. We divide that side by x as well. So now I'm left with y equals. I'm just going to bring it right up over here. So y equals. I'm going to put the 2x first. So 2x plus 1 over x. Again, this is the inverse, so I'm going to rewrite y using inverse notation. So it's that right there. So there is my inverse. Now, it also says to go ahead and check to make sure, to verify that it is my inverse. All right, now this is going to take a little bit of space. All right, so what I want to do is I'm going to go ahead and just take it and look at a separate sheet. If you guys have some blank space in your notes, you want to verify it there. But I'm going to verify next, and I'm just going to put a little note here so you remember. So verify, and we'll put right here on separate sheet. All right, so we're on a separate page, something like that. You might want to draw an arrow to where you put it. So I'm going to put on my verification right over here on this next page. So my original function was f of x equals 1 over x minus 2. And we said my inverse function was 2x plus 1 over x. All right, so if you remember back what we were talking about, we were talking about composite functions. The very thing at the very end was talking about determining whether or not things were inverses. So the way we did that is in the notes we say we would do f of g of x. All right, but in this case, g of x represents my inverse function. So in this case, we're going to do f of my inverse function. And remember, when we do that, we should get x. All right, so again, this is a little bit of a lengthy process because it's so involved and it's got a fraction. So let's look at that first. All right, so remember, there's two steps. So that's my first part. Let's do f of g of x, or f of my inverse. So that means I'm taking my inverse and plugging it in. So that means in place of this x here, I'm taking my inverse function and substituting it in. All right, so this is going to be 1 over. In place of this x here, I'm going to put in 2x plus 1 over x, and then minus 2. All right, so I've got 1 over x minus 2, and again, this is my inverse function right here. All right, let's see if we can, there we go. All right, so now from here, it's just simplifying. Now, it looks difficult. It looks like, how in the world are we going to get x from this? All right, so what I want to do is I'm going to write this 2 a little bit higher, because I'm going to write that as 2 over 1. All right, now we talked about, we did a problem like this similar earlier the other day. All right, if I've got a fraction here, if I'm going to subtract or add two fractions, I've got to have a common denominator. All right, so right now, if you look at these two fractions in my denominator, one of them has an x and one of them has a 1. All right, so my common denominator between the two will be x. So what do I need to do to 1 to make it an x? Well, I got to multiply by x, and I got to do the same thing in the numerator of that fraction. All right, so when I do that, I'm just going to take it step by step, don't rush it. So I've got still 2x plus 1 over x, but now that I've multiplied by x, for the other piece, I got minus 2x over x. All right, so that's what I've got so far. All right, so let's go again step by step. Let's take our time. Let's show each step so that we make sure we're not missing anything. All right, so I've got a 1 over. Now that they have a common denominator, now I can combine those. So that'll be 2x plus 1 minus 2x, and all that over my common denominator of x. All right, so from here, what I want to do is let's go ahead and see what we can combine. So right up here in the numerator of my denominator, if that makes sense. All right, that piece right there, if we combine, all right, I've got 2x minus 2x, which is 0, so I'm left with a 1. So I'm left with 1 over x. Now, we've talked about it before. If we have a fraction divided by a fraction, the way we undo it is to multiply by the reciprocal. Now, the reciprocal of 1 over x is going to be, remember reciprocal means I flip it, will be x over 1. And x over 1 is just x, which is what I was looking for. So check. So far it looks like this is in fact the inverse. But remember, there are two parts to check it, to verify. The first thing was do f of g of x, in this case f of my inverse. The second part of that was to go the other way, to do g of f of x, which in this case means to take my original and plug it into my inverse, which again, we should still get x. All right, so now if I go back up and look up here, now I'm going to take my original function and plug it into both x values here. All right, so it's going to be a little bit more involved. Again, this verification part, especially because we're dealing with fractions, it's going to take a little bit more time, but that's okay. All right, so let's take my original function and plug it into my inverse. So what that means, my inverse was 2x plus 1 over x. So that means in place of this x and in place of that x, I'm going to plug in my original function. All right, so I'm going to have 2 times my original function was 1 over x minus 2. So I've got 2x plus 1 over, now same thing in place of this x, I still got to put the same thing, which would have been 1 over x minus 2. All right, again, it's a little bit more involved, takes a little bit of time to take it step by step. You won't have too many of these, because some of these do take a little bit longer. All right, so if I take this 2 and I distribute it, all right, that's 2 over 1. So when you multiply fractions, 2 times 1 is 2, over 1 times x minus 2 is just x minus 2. I've got a plus 1, all that over, and I've got a 1 over x minus 2. All right, now, if you look up here in the numerator, just like in the previous part that we did, right up here, I've got a fraction plus a fraction. The only way to add fractions is they have a common denominator. So what I'm going to do here, my common denominator between the two will be x minus 2, so multiply by x minus 2 here, and by x minus 2 here. All right, that's going to help give me my common denominator. All right, so instead of trying to do it all in my head, I'm going to bring it all right down here. All right, so I've got my 2 over x minus 2. I didn't manipulate that at all, so that's still there. Plus, now if I take this 1 and I distribute it to both pieces, 1 times x minus 2 is just x minus 2 over, same thing here. The denominator, you got 1 times x minus 2 is just x minus 2. All that over my original denominator with this thing. So now in my numerator, so notice up here, I now have a common denominator, so now I can go ahead and combine those. All right, so 2 plus x minus 2 over my common denominator is x minus 2. Now it looks like it was getting ugly, but you'll start seeing it should start cleaning up a little bit. All right, so notice up top, 2 minus 2 is 0. Those cancel each other out. So I'm just left with x over, and I've still got my x minus 2 in the denominator, all that over 1 over x minus 2. So once again, I'm kind of left with that same predicament of a fraction divided by a fraction. All right, so same thing we did before. If I got a fraction divided by a fraction, dividing by 1 over x minus 2 is the same thing as multiplying by that reciprocal. So the reciprocal of 1 over x minus 2. The reciprocal of 1 over x minus 2 is x minus 2 over 1. All right, and if you notice, your x minus 2's will cancel, so I'm left with x. So both parts, my original part right up here, this part gave me an x, as well as this piece. So when I plugged my inverse into my original, I got x. When I plugged my original into my inverse, I also got x. So therefore, that was, in fact, my inverse. So looking back at what we were doing here, my inverse officially is 2x plus 1 over x. So again, we verified on a separate sheet. It took a little bit more time with more pages. That's why we went ahead and did that. So what I want you guys to do is jump down here and take a quick second, or take a minute or so, and look at this last function and go through and find its inverse and then go ahead and verify. All right, so let's go through this second function here. So first of all, we got to find the inverse. So first thing is I'm going to take f of x, I'm going to change that to a y. So y equals x squared plus 9. Second step is I'm going to flip, or take the inverse, or flip my x and my y value. So in place of y, I'm going to put an x. In place of x, I'm going to put a y. All right, so the next step of this is to get y by itself. So right now I've got y squared plus 9. So first I got to move that 9 over, so subtract it over. So I'm going to have x minus 9, can't combine those, equals y squared. And the last step is going to be to take the square root. So I'm going to get y by itself, so I'll take the square root of both sides. All right, so I'm going to have y equals the square root of x minus 9. All right, now the last step would be to change that to inverse notation. So the inverse of f of x is equal to the square root of x minus 9. So that's my inverse. So now I need to go through and I need to verify. Now this verification will be a little bit quicker. All right, so first thing I need to do is we're going to take and do f of g of x. But again, g of x just represents your inverse function. So you could see it like this as well. So that means I'm taking my inverse function and plugging it into my original function. So I'm going to take my inverse, all right, and plug it into my original. So my original is x squared plus 9. So in place of this x right here, I'm going to plug in my inverse. So I'm going to take this and I'm going to plug it in here. And again, I should get x if it is in fact my inverse. So in place of that x, I'm going to put in my inverse. So that's going to look like this. I'm going to have the square root. All right, sorry for that little interruption there. So once again, we're taking my inverse function, we're going to plug it back into my original. So in place of this x, we're plugging in my inverse. So I've got the square root of x minus 9 squared plus 9. So again, in place of that x value there, I'm plugging in my inverse. All right, so again, we're looking to see that that value is in fact equal to x. Once I plug that in and simplify, so let me get rid of that, get a little bit more room. All right, so when you square a square root, those cancel each other out. So I'm just left with x minus 9 plus 9. And if you notice, negative 9 plus 9 gives you x. So that one was significantly quicker. All right, so again, the square root cancels out, so I'm left with x minus 9 plus 9, your negative 9 and positive 9 cancel out, so we're good. So that's the first step. The second step, then we do the opposite, so we did f of g of x first. So now I'm going to do g of f of x, but again, g of x represents my inverse function, so it could also look like this. Right here, so this means now I'm taking my original function and I'm plugging it into my inverse function. So my inverse function, just like you see down at the bottom left, is the square root of x minus 9. So what that means is in place of this x value here, I'm going to plug in my original function, which was x squared plus 9. So that's going to look like this. We have the square root of, in place of that x, I'm going to put my original function, which was x squared plus 9. Oops, that should be a minus 9. There we go. So we got a minus 9. So again, that's my x. All right, so square root of x minus 9. All right, nothing can simplify, so I'm going to drop my parentheses. So it's the square root of x squared plus 9 minus 9. Your 9s are going to cancel here. 9 minus 9 is 0. So I'm left with the square root of x squared. Similar to what we said before, when you take the square root of something squared, that's just going to become x. So there you go. Once again, we've shown that that is my inverse. In fact, square root of x minus 9 is my inverse. All right, so that's going to be it here. All right, so that's the end of section 4.2. You got some homework in the book. So I want you guys to focus on that homework in the book tomorrow. Next week, you guys will get some practice with that going into the following week. So again, remember guys, Monday, you guys do not have school. You guys have the 13th off from school. So Monday, enjoy your day off. And you guys will be back Tuesday to go more practice for 4.2. We'll start at 4.3 on Wednesday. Hope you guys have a wonderful weekend. See you when I get back.